Hello, Mr. Mick here, helping my Intro to Computer Science Python students with understanding the board game project demo program and how to work on that assignment productively. Here it is in 2017-18. The program that you see in the future might be slightly different, but hopefully this video will help you understand what you have to do. Okay, so here's the program. Let's run the demo program. You'll see it looks like a board game, and when the person presses the letter key on the keyboard, a random number is rolled, and the turtle moved 4 spaces because the dice roll was 4. Remember, he or she started here, 1, 2, 3, 4. The player 1 is now on square number 5. This is square 5. 1, 2, 3, 4, 5. Now if I press R again, the next roll was a 2. Well, no, sorry, turtle. The turtle was there, and he moved 2, but he hit this special square called reset, so he went the whole way back. So player 1 is now on square number 1, even though he technically did reach square number 7 temporarily. Another press of the letter R rolls the imaginary dice. That dice roll was a 3. He went from here, 1, 2, 3. Another roll of the dice, only a 1, so he's on square 5. Another roll. Oh, he landed there. There was a slight pause, and then he moved ahead 2. So he landed on 9 with a roll of 4, and then he went 2 more because of the plus 2, so he's now on square 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One more press of the R. Wow, that was a good roll. Dice roll was 6, and he went from 11 to 17, and there was a pause there for a second. It was announced that player 1, the only player in this version of the game, wins, and he was automatically reset, where pressing the letter R again, he unluckily rolled a 6, which means he reset, but anyway, you can play as many times as you'd like, and it resets after a little pause each time, and so on. Okay, let's trace the code. You've already read the specs for this assignment thoroughly, and you're following the instructions in the specs, at least the version that you see, and here is the code. Let's do a walkthrough of this code. First of all, notice that this code, this program involves a lot of functions, DEF functions. All that code was indented there because this code right here is in the body of the function named to draw square. I'm going to shrink it up there with that little triangle. I'm using trinket. Trinket allows you to do this. I'm shrinking up all the other functions. So these functions are nicely separated here by green hashtag comments. And all this code up above is more or less code that runs one time, setting up the screen, making it look good. And the main program, the main action, is really just this code right here. So let's jump in, let's look at the top. Constants. These constants will be used somewhere in the code down below. So for convenience, we could change the square size over here from 40 pixels to perhaps 80 pixels. Now it may look really, it may logically not work, but the 40 is there as a matter of convenience anyway. The start position of my turtle is apparently -200 and in the Y direction at 0. Now keep in mind, according to the project specs and just the programming process, you should have first drew your design grid, and here it's hard to see maybe because of these colors, but here are my squares. Each square you'll see is 40 pixels wide and 40 pixels tall. I numbered them on my graph paper, 1, 2, 3, 4, 5, etc. The lower left corner of these first 2 squares, I did plot those XY coordinates. That's the point -200, see, -200 on the x-axis, comma 0, that's 0 on right there, that's the y-axis 0. And this point right here is the point -160, comma 0. Now it's up to you to get a good grade on this assignment. It's up to you to plot the rest of your bottom left corner points of your squares. You don't have to have squares that are adjacent like that. You could have squares that, for example, that could be your square 1. It could have a width of 20 and a height of 30. But the bottom left corner is the point that, according to my rules, at least right now in 2018, that's the point that you would have to plot. For example, negative 160 is the point on the x-axis right there. And on the y-axis, that's the point 140. So somehow you would need to plot that coordinate there and show good principles of designing first before you write code. Before you write code like this, you can't possibly do a good job without first planning out your code on a piece of paper, preferably graph paper in this case, so that you can be efficient writing your code. Anyway, back to my walkthrough of this program. So I'm using a bunch of constants here. The n square is square number 15, the end of the game here. Notice that not just turtle, but I'm importing random and time. They're called libraries. And I'm importing random so that I can use the randint function that generates random integers. I'm also importing time so I can later on use the sleep function, which causes the pause to occur at certain points during the execution of this program. So those lines of code just have to be up there for this program to work fully beyond this point. Okay, I'm not going to go over this code because we've done lots of projects where we set up the screen with a turtle. I named my turtle Pen, and there's another turtle named Player 1. Perhaps you could change in a graphic so that you're not using the turtle shape. You could probably put a background in here by doing all of that up here in this area setting up the screen. Copy and paste from old projects. Good luck with that. Here in Shrinkit.io, you would have to come over here to your graphics area. But for now, this demo project is not trying to wow you with graphics. Okay, so here are the functions that we'll look through later when we get to them. But you know, a function is just skipped over, and it's only called or executed when it's needed. Well, let's jump in where the program would go next here to the main program, draw board. Well, what do you know? Draw board is a function. It was typed out right here. Let's go look to see what code is being executed inside and indented inside that function. Well, the whole game board is being drawn here by the function draw board. Well, the very first line of code in that function is a call statement to another function. Draw square is a function that I typed out right here. And these are called parameters. The negative 200, 0, those two numbers are called parameters. The negative 200 comes up here to where you see draw square and plugs in for x. The 0 comes up here because it's after the comma and it plugs in for y. Let's reveal what code is inside the body of draw square. So all this code is part of draw square, not to be confused with the code that we were just looking at for draw board. So the board, the draw board function, draws all the squares, but it makes use of the function draw square, well, 15 times. The first time, it sends those two numbers up here, and everywhere that you see an x, currently it's negative 200. So because of pen.setX, the pen turtle that's hidden when this program runs, that very first square is drawn because it puts the pen there, it puts it down, it puts it at the y position 0, so in other words it puts it at that point, then it moves forward square size, which is a constant. That's the same thing as the number 40. So keep in mind that we are right here and we're moving forward 40. And then we turn left 90 degrees, which means the imaginary turtle is pointing up. Then we go forward another 40, because that's the same thing as the number 40 there, that square size constant. So it goes up. It makes another 90-degree left turn. It goes forward again to to trace out this part of this first square, and it makes one more left turn and goes forward down to there. Now I'm not sure why it really needs to turn left again. Maybe it turns left just so it's oriented in this rightward direction, so that for the next square, because once this code for this function is done executing, even though there's no return statement here, Python just knows to go back to the draw board function, and it's as if that code is done, and now the computer runs that code. And when that's finished, it runs that code. So in other words, all 15 squares are drawn because of the efficiency of having a function, draw board, call another function over and over again. Of course, we could have put all this code in one function, or we could have just put it all up here and setting up the screen. But by using functions, we can reuse code in later projects or many times over in the same program. So it's just good style, and that's why I'm teaching it to you at this point during the school year. Okay, so a lot of times you don't need to know the details of what a function does inside its body. Just by going by the name of the function, or perhaps just reading the comment that should be there for good style, it tells you what that function does, and you can just trust that it works. Roll die, that rolls a single-sided dice. Because it uses the built-in rand int function that comes from the random library that we imported, random.randint, gives you a number between 1 and 6, between or including those two endpoints. It will not give you decimal numbers, it only gives you a random integer. And whatever that number is, it could be 3, it could be 4, it could be 1, it gets returned, and anyway, later on we'll see where the roll die function is used. Move player, just a quick introduction to that function. It moves the player as necessary through the board using if statements that we've studied, and we'll trace that code later on. Okay, so we drew the board, and then we do a game reset, which real quickly and simply puts the player in the start position right here. Now notice we have this variable. It's called a global variable, player position. We're setting it equal to 1. It was also introduced up here somewhere. Player position was set equal to 1 here, but it's also being set equal to 1 here. And instead of setting x to some number, I'm figuring out that you take negative 200 and you add half the square size, which would be 20. That puts your left edge of the turtle about halfway through in the middle of the square. So this is just really good mathematical code that puts the turtle in the middle horizontally, and then because of set y, it's putting the square of the turtle vertically in the middle. And we hide the turtle when we do all that so it doesn't like flicker around, and then we do a show turtle there. So nice little function here that resets the game and puts the turtle right there. And now we're ready to check out that anytime the player, the human, presses the letter R on the keyboard, the function move player 1 executes. So I'm going to do that. I'm going to run this program and press the letter R on the keyboard. And we just rolled a 6 and we hit that reset and move back. So what happens? Move player 1 is the function that we're calling. So let's look in the body of that function. Okay, we just need this global player position, 1 position there because we have to. We'll study those later in class, those things called global variables. And this line of code calls the roll die function. So it comes up here, a number gets returned, and whatever that number is, say it's 6, plugs in here because that's what happens. That return 1 through 6 plugs it in there where we saw roll die empty parentheses. Roll die empty parentheses was right there. So it's as if the number 6 just plugged in there. The 6 plugs into the variable random num that I just created right there. It is not a global variable, by the way. And we're then printing dice roll is 6, prints out down here on the console window because of the print function. Then we're taking 6. The number 6 is still stored in the variable random num. We're taking a 6 and we're adding it to player 1 position. Now keep in mind, player 1 position was the number 1. It was the number 1 because of the code that was in my reset, my game reset function, which I can't find right now because I've scrolled the wrong direction. But if I were tracing all of this on a piece of paper, which I should be doing that right now. So here I am. I should be tracing all of this on this piece of paper, say. Remember, there was a variable called player 1 position, and it started out at, it's a global variable. It starts out with the value 1. Then I have a variable that I just saw called random num. A 6 was just generated by the computer, and we now added that 6 plus equal into that 1. So player position is up to 7. So that means that when I executed this project, player 1 position went up to 7, and that lands us on the reset we'll soon see. Anyway, right here is where we are tracing the program. Player 1 position is 7. Well, this is false because player position 1 is not 1. This if statement is false. This if statement is false. And I scroll down here and this if statement is true. So this code that's indented as the body of this if statement executes because a 6 was rolled and the 6 added to the 1 yielded a 7. And all of this code executes. Well, that puts these two lines of code, if you trace them carefully, set x, set y, it lands the turtle there, which happens to be one of the special squares in this assignment. I then use the famous sleep function that is in the time library that I imported up above. Because I did this import time, I can make the program pause for 1 second, just so that you can see the turtle there for a second. Then I tell the turtle, hey, player 1 position is equal to 1. I keep track of this variable right here, and I change it back to a 1. And then I manually write the code that moves the body of the turtle back to this position that I know is square 1. And I tell the player down here in the print window, player 1 is now on square number, well, player 1 position is 1. So that's why that 1 prints out there after the pound symbol. None of these other if statements are true because we are not on square 8, 9, 10, or up through 15. So none of those if statements are true. And we're done with that function. That function ends right there. So all of that code executed as part of move player 1. And that all happened because we pressed the R. Now let's press R again. Ready? And this time I rolled a 5, which means I'm on player 1 position 6. So technically, behind the scenes, that random number was a 5. 5 plus 1 is 6. That's why the body of the turtle is right now on square number 6. All of this has to do with, of course, my original design here of the board. And the program then keeps running. Every time I press R, move player 1 executes. To close out this video, I'm going to show you the rest of this complicated function called move player 1. It all hinges on whatever number is rolled according to the random number between 1 and 6 that plugs in here, that then gets added to, this was the variable random num there. It gets added to the player 1 position variable. And most of this is just positioning, the -120, 0, the -80, 0, the -40, 0. All of those just land you in these squares based on my careful design that I did, which is, I seem to have lost it right here. So I repeat, you should label all these points and just be able to read this graph system. You would label all those corner points, and your board can be in any shape. I think according to the specs in 2018, you have to have at least 20 squares. I only have 15. And you'll need 3 or more special squares. I only have 2 special squares, reset and +2. And back to the code, let's look at some of the special squares. Anytime you hit a special square like we just saw for 7 where the reset happened, you'll need to do extra code besides just the 2 lines of code that change the X and Y position of the turtle. For example, this +2 happens on square number 9. So I show the turtle land on square number 9 temporarily. I make it pause for a second. Then I add 2 to the variable player 1 position. So I add 2. Well, technically, anytime he lands there, he's on board position number 1, 2, 3, 4, 5, 6, 7, 8, 9. So technically, this would have been a 9. And with 2 added to it, it would go to 11. Sorry. And he would therefore land on this square right here, because when you go forward 2, 1, 2, you would land on that square. That's the only other special square. And then in closing, I'll show you what happens if you land on the end, on square 15. If player 1's position is greater than or equal to 15, which the constant n square up here was set to 15, anytime it's greater than that, if you roll like a 6, but you were right here, you only needed a 1 to win, I make it easy to win by putting a greater than sign there. And that sends you to, well, that square. We pause for 2 seconds. We announce that the player wins down here in this print window. And then we hide the turtle just so it doesn't flicker, and we call the game reset function, which sends the player back to square 1, and it resets the variable player 1 position to 1 for basically a second game. Okay, so there you go. Hopefully you understood some of that. You could always watch this video a couple times, pause it, go in slow motion, and let's just review some tips on how you would finish this project. Well, in the demo project, that if you choose to keep this much of the board, if you don't get creative and you just take this easy board layout, you would scroll down here and you would add at least 5 more squares by copying and pasting that 14, this one here. You would copy that code, you'd paste it here, but you'd make sure that your indentation, this I, must line up perfectly with that I. This P must be, these 2 have to be indented there. You could delete this to do comment, and you would need then, of course, to change that 14 to a 15, and so on. You would need to change those numbers based on the X and the Y of the bottom left corner of your next square, which would actually be, this would be your 15, your N would no longer be there. And then you would find out the XY position of that bottom left corner of this one, and so on. You need to add at least 5 squares to do a decent job on this project. And I recommend that you test it as you go. One thing you could do is hardwire your roll die function, and actually right here, instead of messing with that, you could just make the turtle land right away on, say, square 14. Watch this. By putting a 14 there and hashtag commenting out the roll die function, we're really just telling the computer to roll a 14. That 14 added to 1 will cause him to win the game as soon as I press the R. Check this out. Ready? Press of the R. And he goes right there where he wins, it pauses. Now that's kind of cheating, but as the coder, you can put any number in there you want. If you want to test this reset, 1, that's 1. Okay, you would need to roll 1, 2, 3, 4, 5, 6. So by putting a 6 here, then testing this, and pressing the R, of course, to roll the dice, it's testing my special square, which was right here for player position 7. So that's a little debugging tip for testing your project right there by hardwiring that number. Some other things you can do, of course, is you can if you don't want to always be reset, well, first of all, before I even go over that, you could just roll a 1 every time. And then you can test the positioning of your turtle as you go through the maze. Watch, when I press the R, I'm going 1, but of course I hit the reset, so you have to work around that. So that's a good tip, rolling a 1 each time. And then you can always comment out your code by using the 3 little apostrophes, and perhaps you don't want any of these, especially this reset, to occur. So you put 3 little apostrophes there and 3 little apostrophes here. Then you don't have to worry about hitting that reset because it's commented out there in red. It's in between the 3 apostrophes that you saw there and there. Another tip, just be careful of your indentation and make sure that your code is inside the functions indented consistently and correctly. Always make backups. Please, please don't lose something at Trinket. Duplicate it and highlight all the code and copy it into Microsoft Word or some other location as a backup. Do that every day so that you don't lose important code that you successfully typed. And in closing, there are lots of ways to upgrade this project. Here in the specs, at least in 2018, you can see some other people have done spirited versions of this. I'm not saying that their code is like nicely typed here, but here's a person, Mr. Ackerman, who when you click on this graphic, it shows another graphic and it rolls the dice that way. You can look over his code to see how that works. Here's another variation of where a student did something cool, I'm sure, where this person allows up to 4 people to play the game by typing in numbers here, and then it positions a bunch of people and it looks like dice graphics are being used there. I don't have time to wait for that to, oh, very colorful code. So you can look over, make sure that you don't plagiarize code though. Oh, there's like a bridge and a shortcut to get from one spot to the special squares are doing interesting things. And 1 or 2 more. Here's one that is got a background graphic. I believe this one has background graphics. We've already studied how to use background. Oh, this one also allows you to play the computer. The computer uses the random int function. Oh, actually, there's a similar one called rand rage. So there, the computer, you can try that one out and study the code. So good luck and possibly upgrading this project so that it does more than just the minimum for like a B+ here. Have a great day, and let me know if you have any further questions on the board game project.